one that I was just kind of messing around with. So I can kind of use for a tutorial. It ends up, I ended up using Weaverbird to do the subdivisions on this. Okay, so this is something that could be 3D printed, could be vacuum form. Well, it'd be tough to vacuum form maybe because of the height. So the hardest part about doing this in Karamba is setting up the support locations. It just takes a lot of work in Grasshopper to set that definition up. I'm starting to get a better grasp on. I found this somewhere on the web, someone came up with it. I don't 100% understand the logic of finding the columns, but it's one of those things that I probably have to do maybe 5 or 6 times to totally get it. So we'll just kind of go through the process. And then you'll have the definition, and then we'll move on to how to do the form finding. So if I load Grasshopper, just to show you how this works. So, you know, the idea is that this is done through applying load in a direction load. So these loads, this is inverted. So, you know, with a hanging chain, this would be 180, and the forces would be gravity coming down on it. But now we don't have to work inverted in the computer. So these forces are just, you know, coming from underneath. They're in the positive z, and this thing is pinned down in 1, 2, 3, 4, 5 locations. And it starts out as a flat grid. And instead of pulling up points, we're letting gravity raise this up, and we're just telling it where to hold it down at. And if I show you, where's my form at? Oh, okay.
Chill.
So one of the issues with I don't know if it's the latest Grasshopper, but this version of Grasshopper that I have, you can't do show full names and formulas. It's a glitch. I'm surprised more people haven't bugged David Rutten, the guy who makes Grasshopper, to fix that. And even when I change it back to not show full names, these are red because I have a couple formulas in there. So I actually have to, and you'll run into this, I actually have to recreate these capsules. Hopefully it doesn't crash.
knocked it over.
Please, you're right there on the other side.
Okay, so now this is working. Okay, so here you see the, it's taking this mesh, which is what you see in red, and you see I put these little circles in, to kind of show where the pins are. And there's another pin in the middle. The color gradations are just representing the stress on the areas. So I think green would be where you have the most, and yellow the least, and then you see the gradient in between there. Okay, so the hardest part of it is setting up this part of the definition, which these are the anchors, and if we do this correctly, we can think of these as the mesh plane. Okay, so this, if I move this around, this slider, why it's not letting me? So this circle is following that. And then the surface is reacting to it. Same with this one. What's that?
What's it doing to the surface when it's showing the structure?
Yeah, so I'm moving where it's actually pinned. So it's like the push pin. I'm moving the push pins around. Yeah, so if you watch, I'll move this one. See, it's push. That imagine that's a push pin there in the far lower right. So you have to set one of these up for each one. So that's this one. So there's a force. There's a force at every one of those locations right now. So none of this is pinned down. So it's just moving up. Which would happen, I think, for sure with the paper clips too, right? If you pinned it down in those areas and you had a whole bunch of paper clips left off and you turned it upside down, they might not have this nice. They might just be straight down, right? What's that? Yeah, yours is like that. Yeah. Moving. I think moving away from the rectangle or the square as soon as possible is important. So in the end, it's just having a mesh that's divided and has points in it. I just happen to start with this square grid. But I think for starters, this is a good point to start, and then we can start to change the edge boundary condition.
What's that panel called? The pink grid panel.
This MD slider, so that's should be here somewhere right here. So for the moment, we have to get into Grasshopper a little bit and talk about how to set the first part of this definition up, which should be a lot of fun. Okay, so if you just start out, and regardless whether you have Karamba or not, this whole first part of it is really, Karamba's the very end. It's really just Grasshopper. So basically starting out with a rectangle. So if you double click and start to type in rectangle. What's that? No, I don't have anything in Rhino, but that's a good point. What I do have in Rhino is the units, or are the units. Now, the new version of Karamba, there's a newer version, 1.04, which some of you might have, supports feet inches. Yeah. So you might want to download that. I didn't. So right now mine is set to meters. My Rhino file is set to meters. What's that? Yeah, you can do it in meters too. I think it supports both. Okay, so right now I have this set up, my units to be meters. It's getting cold in here, huh? Start making some snow.
Thanks, Joe.
Okay, so yeah, the units are meters, and I'm gonna make a simple rectangle.
I undercharged you guys, so.
Now, I did something a little bit unorthodox.
It was actually 770.
I want not just a rectangle. You know, this is giving me a rectangle, but I want a grid. So I have to think of rows and columns here. I'm going to have rows and I'm going to have columns. I have to think about that even now when I'm making this rectangle. So if you make a couple of number sliders, if we make one called so we bring a number slider. This one could be, for right now I'm going to call it size. And actually delete that. If you double click and type in 20, that'll give you a nice number slider that is set to integers and has a decent amount of range. So I just double click, typed in 20, enter. And then I'm going to change this to size. And I did that just by right clicking on the little thing, typing in size. And I'm just going to copy and paste these. I'll call this one X. So X are my rows, Y are my columns.
It's like $6. Buy me a beer.
Remind me not to save, because whenever I save,
Gotta love those moments.
it's hard for me not to save. It's like my hand just does it. Right now, I just typed in 20, enter for all those. I don't know how I came up with 15. Okay. So we have X and Y. For the size of the rectangle, I'm going to be multiplying this by this. Okay, because this is going to be the number. These are going to be, it's going to be a grid, so this will be the number of squares or cells in the X direction, and this will be the number of cells in the Y direction. And then the overall size of the rectangle will be the amount of cells times the size of the cell. So if I double click and if I type in the star, on my keyboard it's a shift and the 8, the star, Grasshopper knows that I want to do multiplication. So it brings out that. So I'm going to keep, I don't know why, but I'm going to keep my size as B and then plug this in. Not that it matters. And that's going to be X. Then I can copy and paste that and replace A with Y. Just make sure size is plugged into both. That's really the key. So just to make that more clear, why and what I'm doing there, if you double click and you start to type in, let's see, if you start to type in square, Looks like you have to type the whole word. And then you find the square grid. Okay. This has 3 inputs. Okay, so it has a size. Well, it has 4, but let's look at the S for size, and then X and the Y. If you plug in size to size, X to X, and Y to Y, you're going to get really what I'm looking for, which is a grid, a square grid. Or what will later be a mesh. What's that? No, I just typed in square. Just square, yeah.
Square grid. Yep.
Does it kind of make sense now? Just a grid.
Yeah.
But the rectangle through the math will always be the boundary. You know, as these things grow or shrink, I'm always going to have a rectangle as my boundary. It's parametric. All right. So now I need to make a mesh, and
Say your units are in meters.
yeah, my units are in meters. I'm gonna have to refer back to this many times. My end plane.
Do a little baby grid.
Yeah, do you too?
We're getting little baby grids on the 0, 0 right over.
Oh, right here,
Yeah.
like that guy.
Yeah.
That's the construction plane. It's just a plane. Is it huge or something?
Mine's a lot bigger than yours. Or a lot.
You can,
Yeah,
if
a
you
lot
go to
bigger.
view, or no, if you go to display, preview plane radius, like mine's 0.5.
Oh, okay.
Display, preview plane radius. What's the default?
8.
8. Gets in the way. Looks like a double grid.
Exactly.
Okay, so yeah, not to confuse the grid we made with the construction plane. Okay, so there's a mesh plane which we were making in Rhino. So if I type in mesh, I don't know if I gotta type the whole thing. Yeah. Mesh space, start to type in plane, you'll find mesh plane. And the B is looking for the boundary, which is going to be my rectangle. Now, I'm just curious. Of course. So I had a feeling it was going to happen. That's why I was curious. So yeah, I'm going to start working on some more less rigid. That's why I meant you guys work on the rectangle for now. I got to figure out how to change the boundaries. Okay. So we'll plug the rectangle in. Okay, now if we look at the mesh plane by itself, so if you have mesh plane selected and you do a select inverse, which is Shift Control I, and then you just right click in the canvas somewhere and say preview off. So our mesh plane is looking for the width and the height segments. Yeah, faces. This is number of faces. It says 10 and 10. Yeah, I don't know why we don't see that. We'll see it in a moment. Let's add another component. I think it's decompose. Could be deconstruct. What's that? What's Control Q?
That one goes on.
I was doing a definition and the guy said, click on Control Key to view, stop using the other
This.
definitions.
Bring that down.
Oh,
Control Q closes graph
Okay, you
tab.
guys can accept Control.
okay.
Size X.
I don't want to use it. Okay. There's a deconstruct mesh, and now I think we'll see what the mesh is made of.
Select everything that control right click on it.
Deconstruct mesh.
Right click
No.
Still called decompose in mine.
In the older version, yeah.
Dakota, look at this.
Okay, so now I want that grid. If you turn on your square grid, if you select your square grid and you right click in the white, you can say preview on. They don't line up, right? So what you need to do to make them line up is just plug in your X to the width and your Y to the height. I'm going to change these numbers so they're not the same. My X and Y. So I know things are working. You guys should, save your grasshopper as we're going, because this is like your document. It's like your little tutorial. Okay, so that's the easy part. This is the hard part. Or not hard, just I almost understand. I looked at it a couple times. So think about this for a second. Range. Okay.
It's hard to use.
You guys, are you guys okay? Yeah?
Does it go to help? Alright, go to mesh, the tab on the top mesh.
That's right.
It's the rectangle with 3 arrow points from the corners.
The first one.
Given direction.
I don't know if it's the same on yours. Yeah, it's under mesh analysis. I mean, you could bring a mesh in too, right? So you could skip all this, sort of. We'll see. And you could bring a mesh in from Rhino and plug it in. I think. Okay. So, just some basic theory here. If we think of this as a surface, just one, let's forget the grid for a moment and let's think of it as just a plain surface. Surfaces have domains, and the domain is
So
just,
my X is just
in a surface, it's two directions. It's X and Y. And we can think of the domain from 0 to 1 in the X direction. And then we can think of it from 0 to 1 in the Y direction. So two domains, 0 to 1. That's why these number sliders, these MD sliders, they're set up just like that. 0, this is 0, 0 in the left. And then this is 1, 0. And if I move that up here, it should be 1, 1. So we need to set that up in our definition, but the hard part is we're going to be translating that into XYZ. Because we're going to have to give it specific coordinates within here. So the first thing to start out with is this range component. Okay, it's going to create a range of numbers, and we'll talk a little bit more about that. So bring out a range. And you see the domain. So I was talking about domain. The domain for that is 0 to 1. Okay, the number of steps is going to be each one of the cells. The number of divisions or steps that we're going to have. It creates our range. It creates a range of values. And we're going to have one of these for the X and one for the Y. So let's go to, if you go to the parameters tab and you drag down that panel, not that panel, do a scribble, and this will be our X. This is our X, because we're going to have a Y. This is, maybe for later, this is helpful. This is our mesh. Dealing with our mesh. Okay, so domain 0 to 1, that's already set. This range, it's the number of steps in the X. So we have to plug the X. That's easy. We're going to plug our X number slider in to the N. Okay. Okay. So looking a little bit further, so there's the domain of the entire grid, 0 to 1, 0 to 1. Then there's going to be each individual domain, subdomains that we're going to be setting up, which is each cell. And that's happening in this construct domain component. Now, the reason that we're removing indices, like we're doing these cull patterns, is I think this range is adding a value, just like within the algorithm. So if you look at yours, like mine, it says 16. When I put my cursor over the R, it says 16 locally defined values, but my number slider is 15. So that range, it just adds 1. It shouldn't. So this culling, it's removing the first one. Okay, so it's removing 1 from the list. Okay. So let's just keep going. So let's do a cull. And it's a cull, I double clicked and type in cull, and it's cull index. and the indice is 0. So however you want to put 0, I mean I could double click and put 0. I could bring down one of these panels and put 0 in it. And then the list, of course, is coming out of the range. So I need to plug that into the L. And then we have 2 of these, so you could take that and copy and paste it. This one? This is this panel here.
You can do a double letter. Make sure it's 0.
Okay, and maybe it'll be a little bit clear why we're doing this, but we're going to reverse the list order, and let me just check. So we're going to do that by right-clicking on that L for list, and we're going to choose reverse. So, like, I get that. Like, we have a list, 0, 1, 2, 3, 4, 5, and when you reverse it, it's going to be 5, 4, 3, 2, 1. We're going to reverse the list. So it should be happening, like, when I put my cursor over this L, it starts with the value, and then this one, it ends with that value. Should. Let's see, this is 1. But I'm removing the first one. Now what I don't get is why they also reverse this one. But it doesn't work without doing it, so I haven't figured that out yet. So you also want to reverse, so you're like reversing the list and then you're re-reversing it? I don't think so. It seems like that's what it would do, but again, I'm not too sure. So let's start at 0. Okay. So from this, we're creating a domain. And it's the 2-directional domain. No? It's this one. Construct. Well, I don't know what it is in your version, but it's the one with the 0 to 1. Create a new numeric range.
Just called domain.
Just called domain. So we're going to plug one call into A and the other into B.
That's one. So just type in domain.
Is it domain components or just domain?
I wonder if Brett would remember.
It's because of search mine. Just like maybe it's check. Domain start name.
Really?
Yeah.
Are you serious?
So I think I think I just need to study this a bit more because it gives the out. Like I understand the output completely, so you have to think of this moving in the x direction, moving horizontal. The output looks exactly what I would want it to be: 0 to some number. You know, whatever. You might all have different numbers. It's 0 to some number, then that number. Like it's consistent. It's like segmenting of length into 15 divisions, which is the amount of grids that I have. Right? Does that work on everyone? How's it work in the older? Does that make sense? Like it's this long item that's divided 15 times, and then this is showing you the division. So it's breaking it down, and there it's calling. So basically, it's calling. It's calling this out as a domain, and then a domain, and then a domain. Each one of these now is its own domain. So how that happened through the reverse and the reverse, like I still haven't figured that part out.
When you hover over the new list, it's the same as it was. It's like it switched the numbers again.
Yeah. You mean here?
Yeah.
And here.
So it seems like
What are the numbers for that? 15.
Well, here it's zeros. Right, that's the list. And then by the time it comes out of here, which is here, so that list
Why is this
is the same as this list.
When did you start this?
Right? Although that has 16 and this has 15.
Because ours are.
There might be an easier way to do this. There might be an easier way to do it.
You just suck. Yeah, you just suck. Oh, okay.
It's like a
I did. It might come back with
not a
me.
conversion failed to fix doing it.
Joe, could you take a quick look at Cecilia?
I did. I don't
Oh.
know why it's
Yeah, see.
because she has all everything's plugged in the same way. It's the same.
Is it maybe this? 0?
Right now it's 0.
But with maybe without a panel? Try a number slide in there.
Just put something on the stuff you read.
X and Y going in there. Oh, okay. There you go. Put your WH.
That work?
X, Y.
I didn't even have to get up to fix that problem. That's the best.
Pay attention. Pay attention.
This kind of stuff humbles me here, this little thing. So we got to do the same thing for the Y. So I'm going to copy and paste this. I'll call this Y. Now just make sure that you plug in the Y number slider to that range that you just pasted. Nothing helps. Whenever you're going to come back and look at this and be lost until you redo it. You get the copy and paste.
How do you put the colors around that group of components again?
Yeah. So here, if I select this, I can Control G. I'm Control G. I'm selecting a group, or what I want to be a group, and I'm Control G. Changing the right clicking to change the color.
Control G to group it, and then change the color. Right click, scroll down. Pay attention. Pay attention. Yeah. This is a tutorial, not a hand-holding session. I'm sorry.
Okay, so eventually these anchors, they're supports in our analysis. Okay? Supports, anchors, and that position index there, you see it. It's looking for X, Y, Z. You could have multiple. All 5 of those can go into one. Our Z's are 0 for now. So getting there is through this formula and this evaluate capsule. But I'm also missing one more capsule to these X and Y, which is this find domain. Find the first domain that contains a specific value. So I lied. I not only have to study these, I have to study that one too. So this is the find domain. I don't know what that is in the previous version. Does it exist?
Find domain.
Find domain. And now a trick to add to a group, like I want to add that capsule to that group. I select the capsule, I right click over the group and say add to group. Or if you ever wanted to remove, same process. I'm going to add to group. And then you need another one for down below. It's still fun to work in Grasshopper.
Yeah. I like to see the outcome.
Yeah.
Zoom extents.
Is there a zoom extension?
No.
In what? Grasshopper?
Yeah.
Yeah, this thing.
What? There totally is.
I was joking.
Oh, there's a zoom select.
There's zoom extents.
Oh yeah, there is too.
Wow. I didn't.
Under view, zoom extents.
Shit.
Can't move it.
No, it's there. View. Then zoom. And you know zoom extents.
Oh, this button.
Oh, yes.
Yeah. The materials. The slate here.
Okay, so we need to start to set up, to move forward, we have to set up these MD sliders. I just double click the type in MD. Two directional slider. 0 to 1 is the default in 2 directions. So let's set up 5 of these things. So just select it, copy paste.
You know what, you're done. Get out.
If that bothers you, like that these things are not in alignment, you know, if that kind of thing bothers you, you select them all and click on the left arrow from Mr. Sparkle.
Mr. Spark.
That's some like reference to The Simpsons or something?
Yeah. I think so.
Guy has a sense of humor.
So how do you make the
It's a random cat. Is that this one?
Yeah. Lol cat.
What was it?
Cat.
What was it?
LOL cat.
Really?
Random.
Yeah, I got it. It doesn't.
We just type it.
Doesn't work.
Yeah, random cat.
Lol cat.
You take it out.
You type LOL.
Oh, cat.
No space. No space.
Type in random.
Really? You gotta type
I got a server error anyway on it. Doesn't work. Random LOL.
I type LOL cat.
Come on.
It's a professional version.
I have the professional version.
They don't allow that in there. So it comes up with ours.
It didn't. I just told you.
Alright.
That's probably just an error.
Oh, now what did I do?
Oh no.
Oh,
Yeah.
is my internet down?
Did you save?
I'm not saving.
Save early, save often.
Is that one of my phrases?
Yeah.
Sounded familiar. Okay. Yeah, what do we do with these things now? So, these, I know they go into a component like an XYZ. So they go into this deconstruct or decompose vector, depending on which software you're in. Which will take the input, like if you plug one in, like my slider is 0.5 and 0.5, it takes those two values and makes one X and the other one Y. Z, it keeps it 0. Yeah?
Yeah.
It's not working?
It is.
It is?
Yeah.
Alright, so you could plug all those in. So now you have 5 X values and 5 Y values. You can move them around so that they're different. if you want. I think it's just freaking out.
Yeah, oh, I saw it. Can you go back? Keep going. That one. Vector. Yeah. Oh, no, that one. It's either decomposed. Oh, there it is. Yeah, that one. That's it. There you go.
Because it's so cold?
Yeah, it's great.
Yeah, like it got cooler, like, right? From this morning?
She has same grass.
Oh man. Just the unsigned. It's not on Carlson Street, it's on Lombard Street.
Shit.
So now those get, that XYZ, it gets plugged in, the X gets plugged into the X N, number to test, and the Y gets plugged into the Y N. see what happens here. 7. I think it, it finds the domain. It finds those points in our grid. Let's keep it simple, like that. Okay. It finds those points in our grid. So it translates this grid to this grid. Okay. You guys okay with that? So now is the evaluate. I'm just gonna take these two. Now I gotta show you where to plug those in.
I don't think our evaluate has a Z.
All right, so to get the Z on the evaluate, you zoom in real close, and you'll find the plus. This is just, and this is for mathematical equation XYZ, not XYZ Cartesian, so variables. Okay, so we got that. And that function,
It updates.
Zoom into the function.
X times.
and it'll be red. I can't zoom in too far. It'll be red because it's awaiting x and y and z. X times y plus 1 plus z.
Zoom into evaluate. We click on the plus sign, right?
Yep.
Now I'm laughing. Now I
Is it just a panel?
Yes.
Sorry.
I didn't mean to say it like that. I'm stretching.
Okay, now
I'm
what,
stretching. I apologize.
what goes where?
Why are you so cool?
I didn't mean to say it.
These find domains, they go in. You think they go into x and y, but they don't. They go into x and z. The F dom, the find domains, those plug into x and z.
That's what I said. I was like,
Because z is not Cartesian, x, y, z is not Cartesian space, so that's just based on this formula.
Yeah. Why is it that?
Could you adjust the formula so
I'm sure you could.
just change Y and Z?
Probably.
Why are you in C and
Do I want?
the bottom one? You plugged in E.
So what is,
She's talking about the neighbor in the F domain. Y domain.
Neighbor. Actually. Croissant.
that? And z is gonna come. Well, because I think he did it because y comes from the y number slide.
Well, now it does. It didn't before.
It didn't.
No. You changed it so it would. Because you were putting the Y
Well,
in
this
the
but
Z.
this is going into z right now.
So the Y's do go on the Y?
Oh, okay.
So Y goes to Z.
Watch you screw up the whole thing. I learned never to do that midstream, but you just do sometimes out of curiosity.
Why?
I changed the formula because Dakota couldn't live with. He wanted X to plug into X and Y to plug into Y, and he wanted it no other way.
So what's the new formula?
But what
Change Z and Y.
So I switched the formula.
Change
I switched Y and Z. Sorry, but
Is there a reason the X is coming from the I and the Y is coming from the N?
no, just me. messing it up. So both come from the eye. Thank you, Jeff. Okay, so we're gonna.
Where does the Z come from?
Okay, Z comes from your Y number slider.
That is C. That one's C.
Take it up with your Y.
Uh-huh. I'm here for it.
I get this. I know what he's doing. I would rather see like X. Oh, it's X times. No, I don't.
Yeah. Why change it back?
No, I think what we did.
Yeah, it's the same thing.
It's the same thing.
What's going on?
You think?
Why are you copying? I also have
What was it?
Because mine's not working.
Very true.
no, mine is not working either.
I know, mine's not working either.
What's not working?
They messed it
Yeah,
up.
mine.
I'm trying to figure out why mine's not working.
You don't have to show full names on, do you?
I do.
That's fine. Take show full names off and redo the component.
I have it at home.
Really?
Yeah.
Take it off.
Delete everything.
I said that in the beginning, right?
Why is that affected though?
Short names.
It's still, it's because of message.
Hold on.
Grasshopper.
Jeez.
I'm sorry.
Full name.
You didn't have to do all that.
That's why. Is it not to do full name?
Okay.
No?
I don't see why that makes a difference.
Who cares, Joe? It just does.
Tutorial, Joe. Come on, sit down.
Wait, what does that mean? Tutorial.
Draw full names. Follow there.
You can't be holding your hand through this whole thing.
Oh, that one.
This is the first year.
75.
This isn't working. That's what it's not.
That's why I said I had to
I need to come back to zero. I look at it like it all spread at once.
I was just trying.
See? Like a just need that landed on the side.
I don't know. I was trying to see if it was gonna mess anything up. Okay, so
All that's red.
I guess.
It's not message anymore. Earlier. No, it's not a message. Because I had the same trouble. How do you do it?
Mine's capitalized. That's fine.
All right, yeah. Let's make a list item. Oh man.
Are you doing that Z?
So we're making a list item, and the list is, I think, the vertices. Let's see. Yeah. So the list is our vertices. So whatever you end up drawing, your list is your vertices of that mesh. The index for the list that you're calling out comes from this evaluate, from this expression.
Oh, there's a. I highlighted something. Where's the.
Vertices.
Okay, so this is just calling out an index. So this evaluate is an index. So it's item 81, item 34. Yours might be different. So it's an item from this list of points. This is like serious grasshopper. You thought 427 was challenging? So if I go down, so I'm just showing you this, I don't know why, but I am. So this is calling out, that first one says 81. So that 81 81st item. It's 1470. That's where my first column is at. So that should be here. 1470. So all this was being done down here to select the vertices, to find the vertices. Glad someone else figured it out.
What? Where's yours located? Where's mine located? Yeah, 1470. Mine too. Where's yours at? No, it's like that. Yeah, I like the one.
Oh, you don't see that? You learned to do that.
It's like 380.
Just the first one.
Okay, so yeah, what's coming out of there? The 5 supports.
I don't know, man.
But the only way to match that, Joe, is to have these values. His is 0.5 and 0.5. Are you having different problems?
This is still 0.5. Woo! Joe, I don't know, man.
All right.
Maybe we should just give up.
Take Brett's studio.
So those are going to be the supports. So if I go and grab some text, and I'm going to call this supports. I'm going to double click and type in supports from Karamba.
So mine stopped working since evaluate. It's bad.
And what happens?
I don't know.
Is it that one? Yeah, that one.
Did you make a new evaluate?
Starts.
Yeah. Wonder why Mike's not doing
Dude, figure it out. Are you driving?
You wanna go?
Yeah, let's go.
I'll drive.
Alright.
Ours is only going to take 20. Well, yeah.
What about the, where's it coming from the back? Let's go back.
Joe. Come on.
What? Oops, sorry. Man, it is blowing so cold. You guys should come over here. It's like 10 degrees warmer on this side.
Feels pretty great.
Okay, so you have to go to display and turn that off and delete it and make a new one.
It connects to the evaluation. And
Dude,
R goes into I. L goes into the mesh.
you can hack yours.
Okay?
Yeah.
That's why Joe's yeah, it's not compact.
If I chose to work it.
His V. V goes into the top one.
So, for these supports, turn on all the conditions. And plug in the list item. Okay, so we're doing form finding of shells versus grid shells versus beams. So surfaces. So we need a mesh to shell component. It's part of Karamba. Mesh to shell. And let me just double check. So our mesh plane goes into mesh. We don't need to use the point input for this mesh to shell. So this is coming from our mesh to plane, that mesh. Okay. So what is a component to bring out early on that helps you decide what, or helps you know what you need is this one. This assemble. Having that out early helps. Okay. That was just, you can do that too. That's like what creates the finite element model. It should be really finite element analysis model. So we have support, we have element, and we have point.
Is there any way to make Scribble not like rotate your
Shift.
Oh, is it?
whole shift?
Drag. You are the man. That was worth. That was worth coming here today. Just for that one little thing. You can't drag with the Alt key anymore. You guys can do it. Do the drag with the Alt key. I love that. Like, start to drag an object first, then press the Alt key.
Nothing.
Start to drag, and then press Alt while you're dragging.
Oh, it stops.
No, it makes a copy in the old version. The Coda's version. That was amazing. They got rid of that. Okay, so we're missing the load. That's pretty much all we're gonna need is the load to keep moving forward. So we need a load.
Control Z. Hold shift. Is this really that hard?
Huh.
Oh my god.
So we need
Can I go from there?
we need a point load, P load. P load.
That's why you said it. Now they're
And it needs to be a load at all of our points. Okay, so all of our points are back here, coming out of the V mesh vertices. Those are all of our points. I think that's my logic. I'll look back. No, I was wrong. Wait, no. Confused now. Load.
Point load.
I'm pretty sure I'm right.
Point to load.
Yeah. Okay. Good. So now the load, it needs a direction and an amount. So that direction is going to be the Z. So I'm double clicking, I'm putting in Z. That's going to go into the vector. But we need an amount to control this, so a small amount. So I'm going to double click and I'm going to put in 0.8. I'm also going to double click